All right, our next agent of erosion is glaciers. First thing to consider is where you can find glaciers, and there are two types that you can find. The first one here are continental glaciers. Those were very prevalent during the Ice Age. Maybe you've seen the Ice Age cartoon movies. The melting of that started about 18,000 years ago and ended about 10,000 years ago. So we've been out of an ice age for about 10,000 years now, and we'll talk more about that later. Today you can only find them basically at the poles, about 10% of the Earth, Greenland, Antarctica, places like that. Of course, you should be copying these down in your notebook, by the way. Okay, the other place you can find these glaciers are up in the mountains. They call them valley glaciers, sometimes alpine glaciers. Why? Because they literally form in the valleys of the mountains, not in the peaks, but down in the lower parts. And I'll show you examples of that here in a minute. Alaska, Montana, United States, but of course other places, Mount Everest, the Himalayan mountains, anywhere where we have high mountains, the Swiss Alps, where we're going to have snow year-round. So, the big question always about glaciers is how in the world do they move? They're these big, giant slabs of ice, and we're talking about erosion, so they have to move stuff as they pick up material. Well, they're very, very heavy, very, very thick, so the bottom becomes partially melted from the pressure pushing down on the bottom, and it turns it kind of into a putty-like substance, and that's what it slides on. Now, they're very, very slow, of course, but they are very powerful, and they can pick up giant, giant amounts of material and move them really, really far distances. Here's just a diagram of the idea of a moving glacier. Up here you have the zone of accumulation. That's where a lot of the snow is going to happen. It's going to grow, and as it grows, it's going to be pushed down through the force of gravity coming down out of the mountains, and it's going to carve and move material. Sorry about the formatting on this. This should say a glacial stream here. This is up in Alaska. Again, here we are in the valley between mountain peaks, and this glacier coming right down through the middle of that is carving away at that land. Just one more quick picture. Again, down in the valleys. That's why it's called a valley glacier. You got the mountain peaks on the side, and it's down in this valley, and it's moving right down through here. A big question to all this is always, how do we know glaciers have been in an area? You go back to continental drift. One of the examples we said was climate clues, and of that idea we said that we could tell that India at one time had glaciers. Well, how do we know that? Two features here, glacial grooves, also known as glacial striations, and glacial polish. Basically, when ice goes over a bedrock, it's going to scratch and it's going to break material up, and that's going to form those two features, and I'm going to show you pictures of those here in a second. Here's the first one. Those are called glacial grooves or glacial striations. These are lines right into the bedrock. They show you actually the direction the glacier went. You can see they went left to right here across that picture. But as that glacier dragged across that, it's basically put scratches right into the rock. Here's that second feature, glacial polish. You see these little sections in which the rock has been polished up. Obviously, that glacier basically smoothed the rock there in some sections. It also shows some lines there that would be more striations, but again, shows you evidence that a glacier was at one time there. All right, we have features from erosion, and we have features from deposition when it comes to glaciers. These are features from erosion. Again, please copy these down in your notebook, of course. These features, erosion, they are carved after material gets taken away from a spot. This is one of my favorite pictures I show. This is a great example of one of the features I just talked about, a U-shaped valley. I can tell a glacier went down through here for two reasons. Number one, you got the U-shaped valley, but also we just talked about glacial striations. You can definitely see some lines going in this direction. The glacier went right down through here, and it carved away, and it eroded away a giant U, forming this valley. And that's certainly an example of an erosional feature. So how does this happen? You start with a V-shaped valley. Water forms V-shaped valleys. They downcut, like the Grand Canyon, forming a V. But when a glacier then comes through, glaciers are much fatter, much wider, much deeper, and they're going to carve a giant U, and they're going to form a lot of these features that we just wrote down. fast forward many years, and all the glaciers have retreated, maybe an ice age ended, and we have, again, these features to see that, yes, this was eroded from glaciers. It is, they're features of material being taken away. Here's our giant U. Here's our hanging valley at a higher elevation than below, and a rat, a horn. A couple that are on here we didn't talk about, but they're certainly are ones that we did. Depositional features are features that are left by the glacier. Now, it gets a little confusing here because glaciers have two different kinds of depositional features. They have what are called till, and I always just call that the bulldoze material. That's the material that's left by the glacier as the glacier retreats. Or, as the glacier is starting to melt, it's going to wash away material, and that's called outwash. Now, how do we tell? This is till, because these are giant boulders. There's no way the meltwater of the glacier moved that. A big giant bulldozer here, the glacier itself, would have left big objects like this behind. There is no other agent of erosion that can move what a glacier can. On the other hand, this is outwash. Here in the distance is the glacier. Obviously, it's melting. We can see the meltwater coming up, but at the same time, it's moved a lot of the smaller material and kind of sorted it, and it's dropping it off. So now that we understand the difference between till and outwash, here are examples of each. These are obviously features formed from till, the bulldozed, and these are features that formed from the meltwater itself. So, last couple of pictures here. This is an example of till. It's called a glacial erratic. These rocks are two different things. Again, nothing is powerful enough but a glacier to be able to put a giant boulder sitting right here on top of that rock. And we even have a giant U-shaped valley right next to it. So, again, a great example of till. And then last picture here, this is an example of outwash. Now, first of all, we have a U-shaped valley in the distance, so I know a glacier came right down through here. And it left, you basically think of a little depression, a little scoop out section that the water has to go somewhere. Well, it fills into that little hole, and you've got a Kettle Lake. So I'm basically standing right here in a Kettle Lake in Colorado. But again, I can see that a glacier came right down through here. Just some stuff on glaciers, a lot of little different features. We'll talk more about that, but hopefully we have a decent start with that. Thank you, and have a good night.